Please subscribe, like, and share. It really helps us out. And of course, if you have any questions, comment below and we will answer you as soon as we can. Hey everyone. Welcome back to the IGCSE Chemistry series. Today we're talking about chemical energetics, also known as thermochemistry, basically, how energy is involved in chemical reactions. Let's dive in. Chemical reactions can take in or give out energy, mostly in the form of heat. Firstly, exothermic reactions release heat. The surroundings warm up. For example, combustion, neutralisation, respiration. Delta H is negative. Secondly, endothermic reactions absorb heat. The surroundings cool down. For example, photosynthesis, thermal decomposition. Delta H is positive. Remember this simple trick: exothermic means energy exits, endothermic means energy enters. The enthalpy change, delta H, tells us how much heat energy is gained or lost in a reaction at constant pressure. A negative delta H is exothermic. A positive delta H is endothermic. This value is usually measured in kilojoules per mole. We use energy profile diagrams to show how energy changes during a reaction. The key features you must label are as follows. Firstly, reactants and products. Secondly, activation energy is the minimum energy needed to start a reaction. Thirdly, delta H is the difference in energy between reactants and products. In an exothermic diagram, products are lower in energy. In an endothermic diagram, products are higher in energy. Exams love asking you to label these, so get used to drawing them neatly. We can measure heat changes in experiments using the following formula. This is where Q equals the heat energy in joules. M equals the mass of substance heated, usually water. C equals the specific heat capacity, this is 4.18 joules per gram degree Celsius for water. Delta T equals the temperature change. Then convert Q to delta H if needed, using moles. Chemical reactions involve breaking and making bonds. Breaking bonds equals energy in, endothermic forming bonds equals energy out, exothermic we can estimate delta H using the following formula. If the total energy released is greater, the reaction is exothermic. If the energy required to break bonds is greater, the reaction is endothermic. Sometimes we cannot measure delta H directly. So we use Hess's law. This states the following. The enthalpy change of a reaction is the same no matter what path the reaction takes. This means we can add, subtract, or flip reactions with known delta H values to find the one we need. Think of it like this: they are different roads, but the same total energy change. So, let's review. Always label diagrams clearly, watch your signs. Positive or negative for delta H. Use consistent units, energy in joules or kilojoules. Practice Hess's law rearrangements. Remember the following: breaking bonds absorbs, forming bonds releases. And that's chemical energetics made simple. If this helped, like, subscribe, and drop a comment. Which topic should we do next, rates of reaction or equilibria? See you in the next one. Thank you for watching our video. Please like, subscribe and share. And comment below so we can clarify things for you.